So good morning, I will present here. 19 says 402 database management system and second year fourth semester. Unit number 5, physical storage and MongoDB. This is topic number 1, B tree and B plus tree. This is a important topic in fifth unit. How to store your data in your database server. So we have using of some physical storages and physical storages to store one by one. Huge amount of data can be available, but you have some limitations in your sector. At that time, you can use some different method in your database server, easily store and retrieve your data from database servers. We go for next one. So what is B tree? The B tree is a self-balancing search tree in most of other self-balancing search tree like AVL and Red-Black trees. Or a B tree is a self-balancing tree data structure that maintain the shorted data and allow the search, sequential access, insertion and deletion logarithmic time. B tree is a generalization of binary search tree in that node can have more than two children. First of all, the trees cannot store in intermediate value, or the data can be randomly can store your database server. Cannot store your database server because it's a sequential search tree. So sequential access another condition. So insertion and deletions and search can be allowed at the time logarithmic process. So we go for next one. So to understand use of B tree, we must think a huge amount of data that cannot fit into the memory. The main idea of using B tree to reduce the number of disk access your process. So consideration for disk-based storage system, indexed sequential access method, MB search tree and B tree. We have used B tree is most important in database server. So this is a property of B tree. One is property one is all leaf node must have same level. And property two, all nodes expert root must have at least m divided by 2 minus of 1 key and maximum m minus 1 of key. And property 3, all leaf node except root node, all internal nodes must have at least m divided by 2 children. And property 4, if the root node is the non-leaf node, then it must have at least 2 children. And property 5, on leaf node within n minus 1 key must have n number of children. And next one, property 6, all the key value in a node must have ascending order in your process. So you take a binary search tree. First, how number of values are available. You can choose one pivot element and allocate left hand side or right hand side. Left hand side is the minimum and right hand side is the maximum. So you can choose one value and compare with pivot element. You can allocate whether compare with pivot element, whether the less than you can allocate left hand side. Whether it is right maximum, you can allocate right hand side. This is a binary search tree algorithm to implement that one. You can choose. This steps to insert your B tree. Step one, check whether the tree is empty, and step two, if the tree is empty, then create new node with a new key value and insert into the tree as a root node. If the step 3, if the tree is non-empty, then find the suitable leaf node to which the new key value and add it to binary search tree logic. So step 4, if the leaf node has empty position, add the new key value to the leaf node in ascending order of the key value within the node. Step 5, if that leaf node is already put, and split leaf node by sending middle value to its present node. Repeat the same until the sending value is fixed into the node. And if the step 6, if the splitting is performed, the root node, then the middle value becomes a new root node for the tree, and the height of the tree is increased by 1. So this is the algorithm For example, insert is a check condition, entry level. Find the target leaf node L. If the L is as less than of m minus 2 entry and add the entry 1. Else the allocate new leaf node L. Pick the m divided by 2 highest key of the L. Move on them to L dash. The insert highest key and of L and corresponding address of leaf node in the parent node. If the parent node is full, the split into the add middle key to parent node. Repeat until the parent node is found not full. So if delete, locate leaf node, remove the entry. If the leaf is less than half full, try reach distributor taking from the sibling and adjacent node with the same parent node. If the redistribution fails, merge leaf and sibling, delete the entry. One of the leaf node merge leaf and merge could be propagated to root node. So this is one of the problem statement. Construct a B tree. Order of 5 following number. We have a number. This is the number. Order is m. Order is 5. So maximum children is 5. Minimum children 5 divided by 2 2.5 and maximum key is m minus 1 5 minus 1 and that is 5 minus 1 4. Minimum key 5 divided by 2 minus of 1 2.5 minus of 1 1.5. Minimum 2 children have one pivot element. So this is the answer for first condition. I have choosing, we will consider B tree order of 5. So 5 minus 1, 4 or parent 4 4 minus and have split your value. So order 5 means at least 4 key is allowed. The internal node should have at least 3 non-empty children. Each leaf node may consist of at least 2 key. So insert 3, 4, 7, 1. So I have insert 3, 4, 7, 1. After 8 value is coming, one check a condition. 1 hour is less than, 3 hour less than, 7 hour less than, 14 hour less than. Okay. So 7 hour biggest one. 14 less than. So I have insert here. Suppose 4 maximum. I have 4. I have children is 5 minus 1 4. So already 4 is available. Fifth one can be not fit into the parent node. So I have split your value and middle of the node. I have insert first 1 3 7 8 14. Which one is the middle one? You can going to upward. Going to upward and 7 is the 7 is upward and 1 and 3 belongs to 7 and 8 4 belongs to 7 means less than 7 and greater than 7 8 and 14. This is the answer for 7 1 and 3 and 8 and 14. So next I have insert 15 5 11 7 which can be easily insert to the B tree. I insert one first 5 can check a condition pivot element check பண்றேன். After less than and insert here and 11 I have checked the pivot element more than value I have insert here and 7 once I check checking condition and verify and insert here there is no problem. Next I have insert value of 13 but we have insert 13 then leaf node is will have 5 key so not allowed. So first I insert here I check the pivot element 7 is the more than value so I already is 4 is available. Once I have insert here after the middle of the value 13 can be upward to nearby 7. So this is the answer 7 and 13 1 3 5 and 8 11 and 14 and 17. This is the answer and step by step you have insert your value. This is the final step of B tree. This is the final step 13 4 7 1 and 3 5 and 6 8 11 4 12 14 16 18 19 23 24 25 26. Suppose here one more values are available can here and middle of the value can be upward to the conditions. Okay, this is the final answer for B tree. Same as B tree, only one condition can be applied in B plus tree. The parent node also appear in the leaf node. For example, I have construct B plus tree F as cube A C L H T U W M R. And first I have insert F and S which apply in sequence order and Q is apply in sequence order, and I have my order is 3, m minus 1, 2 children are most important, and after I insert, the Q can be observed and present in the Q in the leaf node. So this is called B plus tree, and same as Q continue in all words in the tree. This is the final answer. This is the final answer for B plus tree in database server to store your data in the sector. This is advantage of the B tree. You use all idea and describe above a particular B tree. Keeps keys in sorted order in sequential traversing. Use hierarchical index to minimize the number of disk read, and use partially full blocks to speed insertion and deletion, and keeps the index balanced with a recursive algorithm. And one more B plus tree advantages. Record keep fetch the equal number of disk access. Height of the tree may remaining balance less than compared to B tree. We can access the data store in the B plus tree sequential as well as directly. And keys are used for indexing and faster search queries as the data is stored only on the leaf node. So this is a advantage, disadvantages, and going to B tree and versus B plus tree. B tree search key cannot be repeated stored, and redundant search keys can be present. Data can be stored in leaf node as well as internal node. The data can only be shorted on the leaf node. And searching for searching some data in a slower processing, since data can be found in the internal node as well as leaf node. Searching is comparatively faster than data can only be found in the leaf node. Deletion is the internal node are so complicated and time consuming. Deletion will never be a complex process, since element will always be deleted from the leaf node. Leaf node cannot be a link together. Leaf node can be together, linked together, make such operations of efficient.